What's up, you guys? My name is Jason, and wherever you are in the world today, welcome back. It's good to see you. I hope you're ready to take on the day because I got a fantastic video coming right up. I believe that you have the potential to be among the very best software engineers, which is why I put so much effort into making content to help people like you. And it's also why I'd really appreciate it if you could hit that like button down below. Think of it as a vote of confidence to keep me going. First things first, let's get into a winning mentality. I actually think that this is the most important step because it sets the tone for how you approach the problem, both here and in the interview room. So many people fail at interviews because they defeat themselves before they even see the question. But that's not going to be you. So take a deep breath with me and think about why you want this. Comment below which company you want to hire you. Okay. Now, visualize yourself carefully reading the question, then outlining your approach, and finally, visualize yourself solving the problem. You can do this. Let's go. All right, let's read this question together. So we're given an array of integers such that for any element in this array, that element's value is greater than or equal to 1 and less than or equal to n, where n is the size of the array. And we also know that some elements appear twice in our array and others appear only once. And this question is asking us to find all the elements that appear twice in this array. So it sounds like it wants some kind of list to be returned of all the elements that appear twice. And furthermore, it challenges us to do this, to find a solution that doesn't use any extra space and to solve this in O of n runtime. So find a linear solution. As always, it's not enough to just know how to do a single question. It's important to understand the fundamentals. This will guide our approach. So let's talk about the main concepts this question is testing, and specifically how they're being applied. Recognizing these patterns will help you in future problems, and it might even score you some points with your interviewer if you can point them out during your interview. So, looking at this question, there are two important details that stand out to me, and we can use this to our advantage. One, the values within the array are between 1 and n inclusive. Now, they wouldn't tell you this fact about the question unless they wanted you to use this somehow. So as we're thinking of a solution, let's see if we can find a way to use this condition. Secondly, we're told that there are only two cases for any value. There's either one instance or there are two instances. So in a list, any list that we're given, each element appears only once or twice. And, two cases. You know what that sounds like? Binary representation. Additionally, these are some key concepts that are overarching throughout this question, and you should think about these before you start. First, think about arrays. Arrays are blocks of memory that can be used to store information in many ways. We're given an array actually as an input, so is there any way we can reuse this input array? Secondly, think about bit manipulation and binary representations. Now remember that bits can represent binary values such as true or false, and bits don't need to be zeros and ones. Think about how else we can represent bits. Alright guys, let's get started. Let's start by defining our output list. These are the values that we know appear twice. The output list usually doesn't count as extra space, and this is something that you might want to double check with your interviewer. And this fact is important to us because this question explicitly asks us to find a solution that doesn't use extra space. So let's call our output list something like numbers that appear twice. And we can instantiate it as an empty list. Now, I really like these long variable names, especially during interviews, because it demonstrates your logic to your interviewer. And it's a really good way for you to revisit your code later on in the interview, and you'll be able to pick up exactly what you were thinking when you wrote that line of code. So now that we've defined our output list, let's start looking at our input list, which is this list of integers that the question calls nums. We want to look at each value. Let's actually look at the example they gave us, right? This 4, 3, 2, 7 list. We want to move through this list one by one. So for num in nums, we want to move through this list value by value But for any given value, how do we know that we've seen it before in the list? For example, if we're doing 4, 3, 2, 7, 8, 2, how do we know that we've seen the number 2 already? Well, let's take advantage of the two facts that we talked about at the beginning. One, we can use the array we're given as a tracker for the values that we've encountered already. Specifically, we can use the indices of the array. And remember, this question tells us that the numbers in the array all fall within the indices of the input list, this part right here. Otherwise, this trick doesn't work. So yeah, the first fact is we can take advantage of the original input list, and specifically, we can take advantage of its indices. Secondly, how exactly can we take advantage of these indices to know that we've explored a number already? This is the part that gets a little bit tricky, and honestly, it was a little hard to explain with words. So, if it's confusing right now, we'll walk through an example later, and hopefully that gives you a better idea. I think it's much easier to visualize this. So, in order to track the values we've already explored using the indices of the input array, we can treat the values at each index as a bit. Every time we encounter a number that corresponds to that bit, we flip it. Or in this case, we can multiply that bit, or the value at that bit rather, by -1. And if we ever encounter a bit that is negative, the value is negative, that means we've already flipped it in the past, and thus we've encountered that number in the past as well, which means it's occurred twice in our array. And because of that, we can then add it to our numbers that appear twice list. So I know that sounds like a lot. Feel free to listen to what I said again, or we can keep moving forward and just code it out and see what it looks like from there. So for each number in nums, we want to define some kind of some way of hashing that number, right? And we can use the indices of the original nums. Specifically, we can use the index in nums that correlates to the following. Index equals the absolute value of the num that we are encountering minus 1. Now, this minus 1 part is kind of annoying. It's I think this question could have been worded better, or it could have been defined better. In Python, for example, lists are 0 indexed. So we need to shift all our indices to the left by 1, or subtract 1, in order to fulfill this original requirement, such that all values are less than or equal to 1, greater than or equal to 1, or less than or equal to n. So, right, Python lists are 0 indexed. Just writing a note there. So we've defined our index. And I want to circle back again and just remember, anytime we hit num, right? This can be 3 over here or 3 over here. I will be the same number. I will always be the absolute value of 3, which is 3 minus 1. So I equals 2. So at here, the index will still map to 2. And over here, the index will map to 2 as well. And that's important for us. So the next thing we need to remember is that we need to check to see if our bit hasn't flipped. How do we do that specifically? Well, remember, if we know that if the value at that index I is negative, so if it's less than 0, then we know for certain that it's been visited before, because we only multiply it by -1, or we only flip it if we've encountered it in the past. So if the value at nums I is less than 0, we know for certain that it's been encountered in the past. And thus, the second time that we see it, it shows that the second time we see this value, we know that this value is a number that's appeared twice. So we can add the current value to our numbers that appear twice list. Append num. Cool. And no matter what, we should flip the value at that index, indicating that we visited it before, and indicating that we've seen this particular number. So numbers nums at I, we want to multiply it by -1. And once we've done a full traversal of every num in nums, we are certain that we've added every number that's appeared twice to our output list. So at this point, we can return numbers that appear twice. All right, let's try running this code. Oh, actually, I forgot something. Because if a number's appear twice, it might be negative. So we should actually append the absolute value of num. So let's run it again. Cool. It's passed the toy example. And let's try all the other tests. Cool. All right. Let's move on and just take a look at exactly how Python is evaluating this function step by step. Cool, so I've recreated the problem here, and let's walk through it step by step. Our input list is going to be this 4, 3, 2, 7, 8, 1, 2, 3. If you notice, any value in this index is greater than or equal to 1, and less than or equal to n, where n is the length of the list. So length of the list is, there's 8 values in here, and 8 is the biggest number in our list. And the expected output is 2 and 3, because 2 and 3 have appeared twice. All right. So, let's instantiate our function. Let's instantiate our input list. And let's instantiate our output list, which initially is empty. Now we're going to walk through num in nums, right, for each value. So the first one is going to be 4. Our num is 4. Our next step, we want to define the index that represents whether or not we've seen 4 before, which is going to be the absolute value of 4 minus 1, which is 3. So I is 3. And next we check if, the value within nums at index 3 is negative. And it's not, so we know that we haven't seen this value before. So we skip this section, this if conditional, but we still want to remember that we visited this index before. So we multiply the number at this index by -1. It doesn't really matter what number is there. We just want to multiply by -1 as a way of remembering things. So we multiply the number at index 3 by -1. Cool. All right, so we go to the next number. Next number is 3. Same deal, right? We know that I is going to be 2 this time, because 3 minus 1 is 2. And the number at index 2 is positive, so we know we haven't seen that value before. And regardless, we multiply it by -1. Same thing for the next value. I is going to be absolute value of -2 in this case. See, that's why we take the absolute value, because we don't care about the sign. They are all originally positive. The negative is only to indicate if we visited the number, if we visited that index before. So I is equal to absolute value of -2 minus 1, which is 1. And the number at index 1 is positive, so we haven't seen it before. Still, we negate it. All right. Next number is -7. Absolute value of that minus 1 is going to be 6. Index at 6 is going to be positive again. We only negate the value at 6. Next number is going to be 8. Same deal. The index is going to be 7. And the value at 7 is still positive, so that means we haven't visited this index before. So we keep going. And finally, we reach index 5. Now we know that we've seen 2 before. So let's see how this works out. So num equals 2. And because of that, I equals the absolute value of 2 minus 1, which is 1 right here. And we check to see if the value at index 1 is less than 0. And in this case, it's true. So that helps us know that we've seen this number before. And because of that, we can add it to our output list. So now numbers that appear twice has the number 2 in it. And we multiply it again by -1. We don't really have to. In this case, it just makes the code a little bit cleaner. If you really want to optimize it, you can use an if else. But let's continue. So the next number is going to be 3, or rather -3 in this case. Our index is going to be the absolute value of -3 minus 1, which is 2. And again, we see that the value at index 2 is negative, which demonstrates to us that we've seen this. We've seen the value that corresponds to this index before. So because of that, we know that 3 has been encountered before at index 1. And we can add it to our numbers that appear twice list and continue. And then finally, we go to the last number, which is 1. The index corresponding to it, which is 0. This number is still positive, which means we haven't encountered this value before. We still negate this value, and then we finish. We finish going through our list. We know that of our input list, only 2 and 3 are the numbers that appear twice, and we return this value, which is a list of 2 and 3. And that's how Python interprets our method step by step. Hey again, I hope that helped you out. And if something still doesn't make sense, just let me know in the comments below and I'll try to get back to you. Once again, if you haven't gotten the chance yet, I would really appreciate it if you could like and subscribe to this channel. I'm just starting out, so any little bit helps a lot. If you wanted to dive deeper into the concepts we talked about today, there are actually some really great books that I would recommend, and I've added links to these books in the description below. Well, that wraps it up for this one. All the best to you, keep grinding, and take care.